All right, welcome back, you guys. Your favorite pre-cal course. This section, we're going to kind of put everything together and solve a bunch of variety of exponential and logarithmic equation. And then the next section, we'll get into the financial models of exponential growth. And then the last section of chapter 5, at least, will be growth and decay and Newton's law of cooling. But let's go ahead and solve this. There's a couple different ways to solve this. First one, you could put it in exponential form. So 2 to the 4th equals that 3x. And of course, 2 to the 4th is 16, and you divide by 3, right? So you get 16 thirds. I also want you to be familiar with recognizing that 2 to the x and log base 2 of x are inverses. So when you put them together, they'll undo each other. So the other way to do this is you take 2 to that side, so that becomes an exponent, and then you go 2 to that side. Because 2 to the log base 2 of 3x is 3x. And we'll use this approach periodically, or we'll kind of be forced into using this approach periodically. So I want you to be familiar with this. 2 to the 4th is 16 divided by 3. Same thing, right? Let's do it both ways on this one. Subtract 9 both sides. So log base 5 of 4x equals negative 7. And then we'll go 5 to the negative 7 equals 4x. And then that's 1 over 5 to the 7th. I'm not sure what 5 to the 7th is. Seven, 8, 1, 2, 5. And then we'll divide by 4. Okay. You know what? I realized, you guys, I'm so sorry. I realized this is supposed to have parentheses right here. That's how you solve that one, but this is what I wanted. I should have wrote it that way. That's what I want you to solve. Sorry. Solve that one. A more half a step up type of a problem. All right, let's do this one first, and then we'll get into other types. So let's go to the exponentials. So 5 squared, put in the exponential form, equals 4x plus 9. Subtract 9, subtract 9. 16 equals 4x, divided by 4, x equals 4, right? So that's one way to solve that. And again, remember, 5 to the x and log base 5 of x are inverses. So they undo each other. So the other way to do this, again, if the parentheses are around it, by the way, we did solve it correctly the other way if the parentheses were not there. But the other way to do this, if you have log base 5 of 4x plus 9 equals 2, is you notice you have the log base 5 isolated. So you can go 5 to this side and 5 to that side. And 5 to the log base 5 of whatever is that whatever. And notice you'll still get 4, right? Either way. All right, let's solve this next one here. I'm going to use the power property. So log base 7 of x squared equals log base 7 of 16. And so this one, you could put it in exponential form if you want to, but the easiest way to do this now is, again, to recognize the inverse of 7 to the x is log base 7 of x. So I'm going to go 7 to this side and 7 to that side, because 7 to the log base 7 of x squared just gives me x squared. And 7 to the log base 7 of 16 gives me 16. Now, when you solve this, notice I'm going to have plus or minus 4 here. So you got to be careful with these, because if you plug them in, let's plug in negative 4 first and check that. You should check your answers. Make sure that they satisfy the domain. In other words, they satisfy the original. So let's plug in -4. Well, log base 7 of -4, that doesn't work. This is what log base 7 of x looks like. This is log base 7 of x. Its domain is positive. You can't take the log of a negative number. So the only one here that works is 4. Throw out the -4, right? So okay, make sure you always check. Just make sure it fits and satisfies your domain. If not, you better reject it. Okay. All right, this one, what I'm going to do is I'm going to use some strategies from last time. I'm going to get both log base 8s on the same side. So I have log base 8 of x plus 7 plus log base 8 of 2 minus x equals 1. The reason I did that is because I know I can condense those. So log base 8 of u plus log base 8 of v is log base 8 of u times v. So in other words, we got log base 8 of x plus 7 times 2 minus x equals 1. Okay? And now what I'm going to do is I'm going to go, what undoes log base 8? 8 to the. So I'm going to go 8 to both sides. 8 to the log base 8 of whatever is that whatever. So it brings that down. And then I got 8 to the 1 over here. And now I'm solving a quadratic. So I got 2x minus x squared plus 14 minus 7x equals 8. And let me get one side equals 0. So let me get all my x squared on the right-hand side here. And I got 2x minus 7x. I got -5x plus 14 equals x squared plus 8. Let me come up here. Let me add 5x to both sides. And so let me write it. So we got 0 equals x squared plus 5x minus 6. So we got x plus 6, x minus 1. So I got -6 and positive 1. And I would again put those in to the original. Let's check -6. So log base 8 of -6 plus 7 equals 1 minus log base 8 of 2 minus a -6. So notice this is log base 8 of 1. This is log base 8 of 8. So this will work out. Log base 8 of 1 is 0. Log base 8 of 8 to the 1 is 1. And see how that works out, right? So I check that one. I'd also check the 1, and both of them work, right? I'm not going to run through the 1, but if you want to later, that'd be great. All right, similar approach here with this one. I'm going to go ahead and I'm going to condense these. And then I'm going to undo log base 2. Well, log base 2, I got to go 2 to that side, 2 to that side. That'll undo it. 2 to the 5th is 32. So I got x squared plus 7x plus 11x plus 18x plus 77 equals 32. Subtract 32. I got to get one side equals 0. Solve this quadratic. And let's see, that'd be 3 and 15, I believe. And then we got to check each of those. So does -3 work? -15 work? Let's check the -15. Log base 2, -15 plus 11 plus log base 2, -15 plus 7 equals 5. I can't take log base 2 and -4. I can't do that. So that one's out. Remember, I can't take, remember, log base 2 looks like this. Here's log base 2 of x. That domain is positive. I can only take log base 2 of a positive number. Let's go ahead and check the next one. -3. So I got log base 2, -3 plus 11 plus log base 2, negative 3 plus 7 equals 5. So log base 2 of 8 plus log base 2 of 4 should equal 5. Log base 2 of 2 to the third. Log base 2 of 2 to the 3 is 3. Log base 2 of 2 to the 2 is 2. And sure enough, that works out for us. So negative 3 is our only solution on that one. Let's keep going here. Let's go ahead and condense these. Now we've got a minus between the both log base 2. So I got log base 2. I've got x plus 3 over x plus 5 equals 1. And I'm going to undo log base 2. So I'm going to go 2 to that side, 2 to that side. Log base 2 of 2 to the x plus 3 over x plus 5 just brings down that x plus 3 over x plus 5. Again, they undo each other. It's 2 to the 1, right? And then what I'm going to do is I'm going to multiply both sides by that x plus 5. X plus 5 here, x plus 5 here. So we got x plus 3 equals 2x plus 10. Get all your x's on one side. Get all your numbers on the other. So I got negative 7 equals x. X equals negative 7, right? Now let's check it again. Make sure it satisfies our original. Log base 2 of negative 7 plus 3 minus log base 2 of negative 7 plus 5. Well, log base 2 of negative 4 does not exist, right? I'm not even going to finish the rest of it. So that doesn't work. So we just say this whole thing's undefined. There's no solution. Undefined, no solution here. So, by the way, these are called extraneous solutions. Extraneous solutions are solutions that appear to be solutions, but they do not satisfy the original. Again, extraneous solutions. So you got to be careful of extraneous solutions when you're solving these logarithms, especially. So, all right, let's take a look at this next one. I'm going to get all my log base 3's on one side. So I have x plus 1 over 2x minus 1. Again, I use the quotient property to condense those. Now I'm going to undo it. This is log base 3, so I'm going to go 3 to this side, 3 to that side. That'll undo it. 3 to the log base 3 of x plus 1 over 2x minus 1 brings that down, right? Because they undo each other. They're inverses. 3 squared is 9. I'm going to multiply both sides by 2x minus 1. So we got x plus 1 equals 18x minus 9. Solve for x. So I've got 10 equals 17x here. So x equals 10 over 17. And then go ahead and punch that in. Let's check that. Log base 3 of 10 17ths plus 1. That's okay. Plus equals, equals 2 plus log base 3. If I go 2 times a positive number, 2 times 10 17ths minus 1, I'm okay there. So I'm okay. That'll work out for you. Satisfies your domain. All right, here we go on this one. Log base 2, x minus 3 plus log base 2 of x. So let's go ahead and use the product property. So I have x minus 3 times x. Still have minus log base 2 of x plus 2. Again, I'm condensing these, so I have a minus between them. So use the quotient property. I have x minus 3. This is all divided by x plus 2. And that equals 2. How do I undo log base 2? I go 2 to that side, 2 to that side, and that'll undo it. 2 to log base 2 of whatever is that whatever. Multiply both sides by that x plus 2. And so we've got x squared minus 3x equals 4x plus 8. Solving a quadratic. X squared minus 7x, I guess subtract 8 as well, equals 0. So I get x minus 8, x plus 1 equals 0. So x equals 8, x equals negative 1. Well, if I check negative 1, let's check -1. Log base 2 of -1 minus 3. Oh, that's log base 2 of -4. I'm not even going to finish it, so that's out. Throw 8 in. 8's going to be okay for you. All right, what if you've got something like this? You got 3 to the x equals 7. And you notice the 7, it's not like you can write 7 as 3 to the something here, right? So what you're really stuck with is to take the natural log or a log of both sides, excuse me, so that you can use the power property. So I'm going to run the natural log, and the reason I do that is so I can get that x in front. And notice I have x times a number, x times the natural log of 3 equals natural log of 7. So now all I got to do is divide by the natural log of 3. I got to divide both sides by that number. So x just ends up being the natural log of 7 over the natural log of 3. And by the way, note, I could have also just taken log of both sides. And you'd have still ended up with the same answer, which is ln of 7 over ln of 3, whatever that is. Let's do similarly on this. You got e to the x plus 5 equals 4. Well, I got to get the x down, if you will. And remember, the inverse of e to the x is the natural log of x. Remember, the natural log of x is log base e of x. Right? So they undo each other. So let's undo e by taking the natural log. So ln of e to the whatever, which is x plus 5, is whatever, right? The x plus 5 comes down. ln of 4 is just a number. So then we subtract 5 both sides. So we've got ln of 4 minus 5, or -5 plus the ln of 4. Either way on that. Again, this one we've got different bases. It's not like I can write 5 as 2 to the something. So we'll go ahead and take the natural log on both sides. And let's see where that gets us. Take the natural log. Now I can use the power property, so I could put that in front. And it's the whole thing times the natural log of 2. And this also goes in front. And it's the whole thing. Notice there's more than one term times the natural log of 5. And I'll go ahead and distribute that. So I have x ln of 2 plus 1 ln of 2 equals 1 times ln of 5 minus, I'll write this as 2x ln of 5. Of course, the 2 ln of 5 is the number part on that. Now what I'm going to do is I'm going to get all my x's on one side. And I'm going to get all my numbers on the other side. So let me subtract the number here, subtract the number here. So I have x ln of 2 plus, I'm going to write it as x times 2 ln of 5 equals ln of 5 minus the ln of 2. And so what I'm going to do here is I'm going to factor an x out of each of those. So I have x times some number, ln of 2 plus 2 ln of 5 is just a number. So I'm going to divide it by that number. And so we just end up with x being ln of 5 minus the ln of 2 over ln of 2 plus 2 ln of 5. Now the question is, could you like cancel an ln of 2 or an ln of 5? You cannot, because it's being added and subtracted, right? Everything's not being multiplied. If stuff was being multiplied, that'd be a different scenario, right? So this is as far as we can go on this problem. Stop right there. And let's keep going. This one is called quadratic in form. And so what I want you to recognize is this is the same as 3 to the x squared. Power of a power, you multiply that. X times 2 is 2x, right? Minus 3 to the x minus 72 equals 0. In other words, if I let u be 3 to the x, this is the same as u squared minus u minus 72. And how would you solve u squared minus u minus 72? Well, you just factor it into u minus 9, u plus 8 being 0. Well, since u is 3 to the x, let's go ahead and replace that. That's the same as 3 to the x minus 9, 3 to the x plus 8. Notice if you FOIL that back, you'll get the original that we have. So now all we got to do is we have the zero product property. So let's go ahead and take each one of these, set them equals 0, and solve. So we have 3 to the x equals 9. Well, we know 9 is 3 squared, so x has got to be 2. And then over here we got 3 to the x equals negative 8. So I'm going to go ahead and take the natural log of both sides, ln. And right here is a problem. I cannot take the natural log of negative 8, right? Here's the natural log of x. X got to be positive. I can't take the natural log of negative 8. So that one won't produce an answer. So the only one that works is 2. And you could go ahead and plug it back into the original, make sure that that satisfies the original. And it does. X does equal 2. Let's go ahead and do this 2 to the 2x similarly. So this is the same as 2 to the x squared minus 7 times 2 to the x plus 12. We're going to let u be 2 to the x. So we got u squared minus 7u plus 12. In other words, u minus 3, u minus 4 is how that would factor. And u is 2 to the x. So replace it back in, set each one equals 0, 2 to the x minus 3 equals 0, 2 to the x minus 4 equals 0, add 3, 2 to the x equals 3. I'm going to have to take the natural log of both sides. I can take the natural log of 3, that's okay, and then I'm going to put that x in front. So x ln of 2 equals the ln of 3 divided by the ln of 2. So I have ln of 3 over ln of 2. Okay, there's one of our answers. That'll work for you. Add 4 over here. So I have 2 to the x equals 4. In other words, 2 to the x equals 2 squared. So x has got to be 2. Plug that into the original. You'll see that that one will also work. Now let's do one last one here. We got e to the x squared minus 6, e to the x minus 16 equals 0. So we're letting u be e to the x. So this is u squared minus 6u minus 16 equals 0. Let's see, that'll factor into u minus 8, u plus 2, or e to the x is our u, minus 8, e to the x plus 2. So we got e to the x minus 8 equals 0, e to the x plus 2, it's got to be 0, add 8, and let's undo e with the natural log. The ln of e to the x is x, so we have x equaling the ln of 8. Plug that into the original, that'll be okay. Subtract 2 both sides. E to the x equals negative 2, but when I run the natural log here, I can't take the natural log of a negative number, so that's out again. So all we have here is the natural log of 8. That should get you guys going. Thanks so much for taking notes. See you next time.